For the second time at DevFestDC, it's grown like 2x. I'm glad everyone's here. It's a great event. And if you're here, you want to listen to this talk, right? I hope you're in the right room. We're talking about distributed microservices, specifically about metrics and tracing. So when you build an app, you have different components. And typically, you would have like one application, like a Node app, or a Ruby app, PHP, Java, whatever language you want. And it might have like different functions that do different things. And so you have like a users, and then they talk to some business logic, which talks to a database, and then returns a result to the user, right? And when you run into an issue with your application, you want to start debugging it. And so common ways of debugging it include adding logging statements, right? It's the most basic form, but we all do it, and it works great. You put logs where you think things are going wrong, and you see what the variable is or things like that. You can also go more complicated by doing things like tracing, profiling, using debuggers and step-throughing the code and things like that. And this works great when you have a single application that can run on a local machine, right? The problem is, when you go into a microservices world, it becomes more and more complicated. You no longer have just one application running, you have hundreds of applications running. Now, the cool thing about this is that each one of these is individually debuggable, individually updatable. You can write each one in its own separate language that makes sense for its purpose, right? Your machine learning thing can be in Python, your backend stuff can be in Go, your web stuff can be in Node.js, whatever. Every team gets the individual choices to make for their own product. So you get a lot of advantages with this. But when you start growing even bigger, now you just have this like complex spider web of interdependent services. There's no way you can launch all of this on your own machine. There's like thousands of them, right? There's no way you even understand what each one of these things are doing. You might understand your team's specific microservice. There's no way you understand every single one, right? If you're at Google or Uber or any of these companies, or even wherever you're working today and you're using microservices, you might have a general idea of like where things are, but there's no way you understand how that team down the road's code actually works, right? There's no idea. There's no way you can know. And there's no way you can debug this stuff. It becomes literally impossible. Or does it? Because microservices, for all their pros, add network and infrastructure complexity to your system. They add complexity in these ways, right? So, people say, oh, microservices are great, they make all your problems go away. Actually, they cause more problems to occur, right? And if we try to debug and trace and get stats about our microservices the same way that we did for our monolith, we're just going to run into more issues. We're literally taking the worst part of microservices and the worst part of monoliths and putting together and saying we're doing modern computing, right? So let's not do that. What microservices do is they remove code complexity in your system, right? So you no longer have a bazillion-line Java application that no one really understands. Instead, you have much smaller, 1,000-line Node application, 1,000-line Python application, 1,000-line Go application. So it's a lot easier to debug those individual components. And what we can do, because we have those individual components, we can actually automate a lot of the communication and the infrastructure between those components, which we couldn't do when we had a bazillion-line Java application. Because code can't be automated while infrastructure can, especially when you're on the cloud. So what we're going to do, instead of getting the worst of both worlds, we're going to go deep into microservices and use them correctly. We're going to use tools to simplify that network and infrastructure complexity. Remember, by moving to microservices, we added this complexity, but we can use tools to simplify it, right? So one problem I want to talk to you guys about today is distributed tracing. So normally when a function calls another function, it gets put on the stack. You use a lot of tools that can look at your memory, look at your stack, and do that kind of in-memory debugging, your program debugging that's running on your local machine. But when you have hundreds of machines running in a cluster with multiple services everywhere, you can't just attach a debugger to your code, right? we have to do distributed debugging and distributed tracing. So service A talks to service B, talks to service C, then service C goes back to service B, which goes back to service A. Service A just knows that it talks to service B, and that takes 100 milliseconds. It has no idea that it's talking to service C as well. And then service C doesn't really know that the request originated with service A. It just knows that service B is talking to it, right? So you lose context in every one of these hops. And of course, it's always a little bit more complicated than the hello world. For example, this is like a simple, let's say an analytics design, right? So you have your analytics front-end server. Now, a single request going into that might span out to 3 different subsystems, right? 3 different microservices. So you have an ops system, a billing system, and a reporting system. They all do their individual things, but they all need to store data somewhere in a database. So in this case, we're using something like Google Cloud Spanner. All 3 of those will write to the database, which eventually writes to the storage layer, right? Now, Spanner, all it sees is 3 different requests coming in. It thinks they're 3 completely individual requests. But in fact, it started with 1 original request, right? So you lose context completely when you have to do this kind of distributed tracing. And so how many people have seen one of these before? Let's raise your hands. Yeah, okay. So if you've ever seen Chrome and you open the network tab in the debugger, you'll see something similar. It's called a waterfall chart. And so when you have a bunch of different asynchronous processes or synchronous processes going on, you can see the time it takes for each one, right? So here you can see that we call this get method, and it does something in MySQL. It waits for that to finish, then it calls another MySQL, waits for that to finish, and then it calls all these in parallel, right? So you can see here that these operations don't even occur until these 2 MySQL operations are finished, right? So we have bottlenecks and things like that. Now, this is just in one server, right? So you can see the first function, second function, and then the third function in a sense. But when it goes to distributed tracing, it becomes even harder because those functions can be occurring in different computers with different timestamps, with different things like that. So it becomes even more complicated. Here's another one. So that was Zipkin. This is Google Cloud Stack Driver. You can see they all look pretty similar. Again, we have some that are done in serial, some that are done in parallel. And even after this one, we have some that are done in serial, right? So we have nested children, we have all this complicated stuff. Just by one request, does all these things that we have to understand. So if we want to do distributed tracing and not lose that context for every single switch, we have to do a little bit of extra work. First of all, we have to create trace IDs and tags for all the incoming requests. Then we have to take those traces and send it to some sort of centralized collector, right? We have multiple systems. We have to somehow centralize it to understand it. Now, each service needs to forward those trace IDs and tags downstream, right? If any service forgets to forward these IDs, again, we lose all context, right? So every single service needs to do this correctly in your whole system. Every single team needs to agree on a format, needs to agree to do this. It becomes complicated, right? Because people are hard. People are the hardest part of technology. And of course, you have to be able to query and search these traces so you can actually use the data. So now switching gears, let's look at distributed stats. So tracing is great because it lets us find bottlenecks. It lets us find where the hotspots are in our code. But we also need stats. So if you're running on something like AWS, Google Cloud, Azure, things like that, you can get some stats out of the box. Things like CPU usage, things like memory usage, and network traffic. So this is like the Google Cloud Stack Driver default dashboard for a Kubernetes cluster running on Kubernetes engine. And it gives us a few cool things like disk I/O and CPU. And those are useful, but they're really not something we care about, right? We care about business metrics, not really like infrastructure metrics, right? CPU usage might be a good proxy for load, but it's not a direct correlation, right? Disk I/O might be a good proxy for database load, but it's not the exact number. What we really want is number of requests per second. We want latency. We want P99 latency. We want all that kind of stuff, but these kind of out-of-the-box statistics don't give us that information. So what we need is every service, again, to be able to provide meaningful statistics to the collector. And we need to be able to, again, tie these back into those trace IDs and tags so we can see which queries, right, this specific customer using this specific, they added these items to their cart, and that causes weird downstream cascading of failures that, was weird. We need to understand what triggered those weird latencies to occur, right? So again, you need to be able to query and search those. So similar problems to distributed tracing. And I have good news. There's a lot of people who will sell you something that will solve this problem. Yes, so we have, from Google all the way to open source stuff. There's a ton of different solutions out there. You're good to go. Oh God, so which one do you choose, right? What if your team really, really likes, let's pick one here, Datadog and Jaeger, but the other team down the road really wants to use Dynatrace and StatTrack? Well, you guys have to pick one, right? You can't use different systems because, again, like we said, it has to be a centralized system. Otherwise, you can't do this distributed system, tracing and metrics. So now you're basically, pick a vendor and then just go all in. And if you made the wrong choice, too bad, you lose. Or is there a better way? Of course there is. So instead of going all in with the vendor, you can use open standards instead to try and abstract over them. So I want to talk about two of these. One is OpenCensus and the other is Istio. So OpenCensus is for, let's just go through it. So again, yeah, we've all seen this slide, right? Next KCD. This is another standard. There's a, But I think that these two are a little bit different. Basically, instead of trying to be like the standard, they try to provide, great tracing and stats while getting out of the way of developers. And they try to be backend agnostic. So the whole point is you implement this once, and then you can use any backend you want to get the metrics that you need. So first, let's talk about Istio. How many people have heard of Istio before? Okay, only a few people. That's great. So Istio is one of my favorite new things. Just a show of hands, how many people have used Docker? Most people. And then keep your hands up if you use Kubernetes. Okay, cool, perfect. So if you haven't used Docker and Kubernetes, it's just a way to deploy containers and make them run on your cluster. We won't look at that too much. Once you have some sort of machines or containers or whatever running, you actually have to be able to manage the communication between those services, right? So that's where Istio really comes in. It's called a service mesh. And so what it can do is things like request routing, like this request goes to these services, this request goes to these services, load balancing, authentication, failure management. If a service goes down, we'll retry it later. Fault injection, which is really cool. You can actually purposefully create errors in your application to see how it handles it, right? So if a service is too perfect, people become dependent on it. So you can basically turn on fault injection and say 1 out of every 10,000 requests will just fail. So you can test what happens and how resilient your services are. And circuit breaking and things like that. So if you want a deep dive into Istio, I have a video on YouTube and a bunch of code on GitHub. You can go to this, and that link will be at the end of the slides too if you don't get a chance to write it down right now. So what I want to talk about Istio today is the distributed tracing and stats that it gives you. So how Istio works is it basically has something called a sidecar proxy, which is a little proxy that sits next to your application. Then what it does is it'll intercept all network requests going in and out, and then it'll automatically add tracing and stats to those requests without you having to touch a single line of code, which is really nice. So again, service A talks to service B, talks to service C, and then again, all these requests go through the proxy, and so because of this, we are able to automatically add tons of stats to your requests. Okay. Now, where does OpenCensus come into play? Now, when service A talks to service B, talks to service C, that's great, but what actually is going on inside of the services? Istio is only proxying the network requests, not what's going on inside. It has no visibility inside of your code. So OpenCensus are a set of libraries for a bunch of different languages that natively integrates with your code to automatically add tracing and metric collection inside of the code. So in our example that we'll see later on, we're running a Go server, and basically we're able to just attach ourselves to that HTTP server running in our code and automatically add internal visibility into our service. Okay, and now for the demo. So, here. So I'm running a demo on Chromebook, as you can tell. So I'm on Google Cloud Shell, which is basically a free dev environment on the cloud. Just hope that I have internet. So I've created a Kubernetes cluster. Let me go show you that. All sorts of one word. I thought we were a search engine. So I have a cluster called, oh, maybe the internet. Oh, there it is. So I have a cluster called my Istio cluster. It's just a standard Google Kubernetes Engine cluster. If you ever used Kubernetes Engine before, you know, you basically click a button, say how big you want it, and it'll just create a cluster for you, which is super simple. Probably one of the best managed Kubernetes out there right now. You don't have to load Kubernetes for this talk, don't worry about it. You can use both of these, Istio and OpenCensus, on any sort of container orchestration platform, on just raw VMs, on raw metal. Kubernetes has the best support, which is why, and I love Kubernetes, which is why I'm showing it up here. So you can see here, you know, we have a 4-node cluster, it's in the US West. And here we go. I've already installed Istio onto this cluster. It's really simple, you just like follow the instructions online. So what we're going to do is deploy 3 different microservices onto our cluster. So I'm going to show you some Node.js code first, because I write Node.js, and I think it's a lot easier to understand. So let's see. Can everyone read that, or should I make it bigger? Okay. No one said anything, so I'm going to say everyone can read it. Okay, so it's really simple. Basically, we have a web server that's listening on, you know, just like the slash. Then we have this thing called an upstream. So in this case, it's just time.jsontest.com. So what it's going to do is it's going to get the current date or the current time. Then it's going to do a request to that upstream, right? So it's going to call that upstream service or downstream service, sorry. And then it's going to get the end time and then basically print out the response from the downstream service with the start time and the end time, right? So it's kind of like just, you can basically daisy chain a bunch of these together to create like an infinite chain of microservices. Okay. And that's basically it. And so the reason why I show you the Node.js code first is because OpenCensus doesn't have support. It has some support for Node.js, but it's still really alpha. It has better support for Go, which is why when I did this talk, I rewrote this in Go. And the code went from this, literally this, to, this is, I don't know if any Go developers here. It's okay. I still love you. It went to this giant thing. It's the same functionality, I swear. Except now we've added OpenCensus to it. So all we had to do to add distributed tracing is basically we import in our OpenCensus packages. So Jaeger is going to be our tracing system. And then OCHTTP is the interface for the default HTTP server in Go. So what we do is we set up our tracing endpoint. So each team can basically say, I want to send stats to whatever endpoint I want. And then we just literally put in this HTTP handler when we have our listen and serve function, right? So our code doesn't have anything to do with OpenCensus inside of it. It's just standard Go code for our HTTP server. It's just really long because it's Go. And all we had to do was basically send it this handler in, and we automatically get distributed tracing. So let's deploy this and then see what it looks like. So here. Okay, so here we have our code. We built it into a Docker container. Now what we're going to do is actually deploy it. Deploy stuff, right? That's the most elegant way of saying stuff. So, and again, don't worry about the Kubernetes stuff too much. I'll explain it. So it's spinning up a ingress. So what we're going to do, just to, if you are familiar with Kubernetes, you can see that it's pretty straightforward. We have 3 different deployments. One for our front end, and we're going to put that container with that code. And so here we're going to give it some environment variables, like the upstream URI. So it's going to, front end is going to talk to the middleware. And we're going to get the Jaeger endpoint from a config map. And don't worry about that too much. And then the middleware, and then the deployment for the backend, right? So we have a front end, a middleware, and a backend. The front end is going to talk to the middleware is going to talk to the backend. And then, of course, the backend is going to talk to absolutely nothing, so it's just going to respond to empty, right? Okay. So we have these 3 services. If you say kubectl, you can see that they're up and running. We have 3 of them running. Now, again, we have literally added nothing except one service talks to another service, talks to another service, and then back. We have added no tracing code. We've added no stats. We've added absolutely nothing to our code except for setting up Jaeger as the endpoint for OpenCensus. In fact, we actually didn't really need to do that at all because Istio will automatically send stuff to the Prometheus backend that's already been configured. So we actually didn't have to do anything. It's nicer to do that so we can do the next step and it will make a little more sense. So here, let's go to Jaeger. Why are you doing that? I don't know. I know why. Because I did silly things. 1 second. Let's see. Well, first of all, let's go to make sure everything's just working. Spell that wrong. Okay. It's not even spinning up. Oh no! Alright, so let's actually see what's going on. For 1 second, sorry, it always happens when you're giving a live demo. Alright. I swear it was working right before you guys showed up. Okay, so nothing's working. That's great. That's working. That's not working. This is not working. Alright, well, we'll see. This is a very boring talk, but live demo doesn't work, so we're going to get it to work. Maybe I didn't launch this too. I didn't launch Istio. Okay, so if you don't install Istio, your demo is not going to work. Clearly. Okay, so. Let's delete everything and start again. Okay, so first we're going to deploy Istio. And you can actually say it's actually pretty fast. So here's how fast it is. So it's going to basically create a bunch of different custom resource definitions, a bunch of custom things. It's going to install Prometheus. It's going to install Grafana. It's going to install Jaeger is going to install all our metrics and tracing dashboarding and things like that. And so all this stuff actually lives in its own namespace, so you never actually see it, which is really nice. Ugh, it failed. Oh. All right. I know why it failed. So I actually, yeah, that's such a silly mistake I made. Okay. So don't try to cheat your way through and be lazy. You should just wait for your computer before putting it to sleep. That is the... One second. Basically, I didn't create this. 15 minutes. Okay, can I delete the cluster and recreate the place I can? I'm going to do it. So while that's going on, what I'm going to do is pull up YouTube and show you my previous video where this is all working. I'll show you some stuff. So I don't want to waste your time. So Istio 1.1. Oh my god. I spelled it wrong, and that's what comes up. Okay, here we go. Anyway, that's weird. So what we're going to do is show you. Where is this? So here are the, where is this? Okay, I'm just going to show you this like as a screenshot. That's fine. So with Istio, we actually get all this stuff out of the box, which is because it's doing all that network-based tracing and routing and things like that. We're actually able to get number 500s, number 400s, average latency per request for each single microservice, right? And we get, this is the default dashboard, but you can get all these stats directly out of Prometheus or in Grafana and make your own dashboards. And the really nice thing is, again, we didn't have to write any code to be able to get all of these detailed network level statistics. But of course, all we have here is the network level statistics. We don't see anything inside of our microservices, right? So we don't really understand why we're getting 500s. We don't really understand why the latency is higher. So what we can do actually is, let's see if this is done. Oh, it's deleted the cluster. I have to create the cluster. So, and then in terms of tracing, what we get, again, because we have, graphics are really bad. So when it comes to tracing, again, because Istio is tracing all the network requests automatically, we get the network going from A to B to C. So in here, we can see that our front end goes to our middleware. Our front end right here goes to our middleware, then goes to our backend. And in this demo, our backend was talking to time.jsontest.com. So you can see that obviously that takes the longest amount of time because it has to go to an external site on the internet and then come back. So here we can see that backend is clearly the bottleneck here. But again, we can't see what's going on inside of the service. So we get both stats for the network and we get tracing for the network. But without OpenCensus, we only get the outside of the box picture. So when we want to look inside the box, we have to add OpenCensus to our code. So again, in this code right here, all we used OpenCensus for was for the tracer, to trace the header propagation, but we didn't actually use it to look inside of our code. Okay, let's look back here. Creating a cluster. You can do it. What else can I tap dance on? So let's actually look at the full code for this. So here, we again have Jaeger. And now we're also going to put in Prometheus as our stats exporter. So the really nice thing here is, say if I want to use Google Stackdriver, I can just put in a Stackdriver exporter, and all of my code stays the same. So our ops team can just give us like this little package that defines these exporters, and then we can just write our code without really caring where it's going. So what I'm going to do here is create some fake things that my application will do in order to create more traffic. So I'm going to basically randomly generate Fibonacci numbers because Fibonacci is done recursively and it takes time. So I want to see how many times this Fibonacci function is called, and then I want to see how long those Fibonacci functions take to return. So I'm going to make a new thing called a fib count, and it's going to be an int64 stat. So it's going to be a count, right? So fib count, it is a count aggregation. So there's different types of aggregations. There's mean aggregations, count aggregations, things like that. So for different types of stats, we're going to do different types of aggregations. And then we're going to basically say, trace every single request. Obviously in production, you don't want to trace every single request, because that's a lot of overhead. And then we're going to report every second. Great. So again, after we set up these custom statistics, fib count, all we have to do is add that handler to our HTTP server. And what we can do now is, so we're going to basically get a random number and then run Fibonacci that many times, right? So we're going to random Fibonacci number between 25 and 30. We're going to check if that number is odd or even, and then return true or false. Yes, this is the pinnacle of software engineering. So in Go, we use something called context. In Node.js and things like that, you don't use context, but in Go, you pass context around, and that's what basically lets us see which one's a child of which one. So in this case, we're going to create a context from the incoming request. Then we're going to create a new trace. And so this fib span, we're going to say start here and then end here. Right? So we're going to call this odd or even function and then pass it in that context that is added with this trace. So in odd or even, we can see here that we're going to create yet another trace, another span, and we're going to actually calculate the Fibonacci number itself. And then because I didn't know what else to do, I'm going to sleep for 3 seconds and then make that into another trace. So basically it's one function calling 2 sub-functions, right? And so we want to see how much time each one of those sub-functions takes. And then if it's even, we're going to return true, otherwise we're going to return false. And then of course our Fibonacci function will do stats that record. So again, every time we're calling Fibonacci, we're going to add 1 to the count. And then it's recursive, so we're going to keep doing it every single time. Okay, hopefully now, yay! All right, so now that we have Istio actually created, this should actually work. Okay. Now we have to wait for that load balancer to spin up. There we go. That looks much better than before. Okay, so let's run this. No healthy upstream. So that just means our containers are still spinning up. So if we go here and take kubectl, you can see that they're in the pod initializing phase. So this is a really cool thing about Istio is that, again, our code doesn't know anything about Istio. What it'll do is when we launch a container onto Kubernetes, it'll actually use something called a mutating webhook, and it'll basically say, hey, you need Istio, and it'll basically shove itself into your container as a sidecar, so there's another container running next to your container, without you, the developer, having to specify anything, right? So at this point, everything should be pretty much running. So one is running, the back end. The front end, the middleware is still spinning up. There we go, everything is running. So now if we go back here, we can see that the front end goes to the middleware goes to the back end. And it's saying how much time each one takes, right? So now let's update our code to use version 2, which has all of that custom stats and custom stuff in it. So now if we hit refresh, obviously, it's not fully done yet. 1, 2, 3, everything seems to be running now. So everything has to break today, huh? All right, I see how it is. That's okay, it just hates me. we're getting 404s, right? So let's go to our dashboard. So if we actually go to our Grafana dashboard, you can actually see those 404s coming up in real time, which is cool. When it loads. Load, okay. So you can see here we're getting, not getting 404s, so that's weird. Why are we not getting 404s? Interesting. I don't know what's going on anymore, guys. I clearly failed you as a presenter. That's okay. I swear it works when it works. Interesting. So let's actually look at, see if we get our custom stats. So okay, so here's at least our front end is giving our custom stats for the number of times it's calling Fibonacci. I don't know why it's not calling our middleware. And it's not giving me that. Well, that's very interesting. So what we're going to do here is also look at our tracing. Wait for it to load. Okay, so we can say our front end and then say let's find some traces. So here you can see that it's not even going to our middleware. So if we click this, you can see that it's just like failing completely. So we clearly have some issues, right? You can see here it's going to our middleware and it's failing. So this is, we're not really sure why it is failing, but we can start debugging our middleware service now. But inside of our front end, unlike before, we can actually see the sub-functions. First of all, we're saying we're calling odd or even here, and then we're calling our Fibonacci calculation and then sleep. So Fibonacci calculation is taking the vast majority of time, and the sleep is taking very little amount of time, right? And now, gotta use your imagination. We would see middleware and the backend here also calling Fibonacci and sleep all nested itself into one big trace. So if you want to learn more, let's go to the end. If this talk worked, again, there's actually a video of this working. So if you don't believe me, it does work. OpenCensus is still alpha right now. That's my excuse for why this didn't work. Istio just released version 0.8, and we're planning to go 1.0 soon in a few months. And so once it goes 1.0, we're going to consider production ready. A lot of people actually use Istio in production already. OpenCensus a little bit less so. More languages are coming out. Node.js finally got support for a lot of stuff, so I'm going to be rewriting this in Node because I do not present the Go code at all. All the code is on my GitHub. You can go check it out. I just pushed up all the OpenCensus stuff. There's no instructions yet, but if you want to go through the Istio stuff, I think I would highly recommend checking that out. Istio does a lot more than just tracing and stats. It can do load balancing and routing and all this kind of cool stuff. If you want to learn more about either of those two, you can go to those links. I am going to go right now to the Cloud Onboard stuff for a panel or something like that, but after that, come find me for office hours. I'm happy to talk about Kubernetes, Istio, Google Cloud, whatever, and I can maybe figure out why this is broken and show you it actually works.